Assalamu alaikum. Welcome to another session of data structures and algorithms using C and C++. My name is Dr. Bilal Wajid, and today we're going to talk about a double linked list and specifically how to add elements in such a way that the double linked list is sorted by default. So we've been talking about a double linked list since lecture number 28. This is lecture number 33. What is quintessential about a double linked list is that every single node has a pointer that points to the previous node and a pointer that points to the next node. And you can have as many different values as you want here. Now, an add function, and specifically the add function that we are talking about, is the one that adds elements in their appropriate place chronologically from small to large. So there are four cases. The first case is, what do you do if the list is empty? The second case is, what do you do if you're trying to add, let's say, a number 5 in this case? Because 5 is smaller than the first element, 10, you are going to add the first node. And the third case is, what if you're trying to add, let's say, a number 15 which comes in between these two nodes? And what happens when you try to add a value, let's say 50, which is larger than all the nodes present? Okay, and we will discuss two of these cases in this lecture and the other two cases in the next lecture, just to ensure that any given lecture doesn't become too long. Now the case one is, the list is empty. If the list is empty, you can check, because you have two global variables, length and start. So if the length is equal to 0, or if start is pointing to null or is equal to null, both of them indicate that your list is empty. In this case, you shouldn't really be doing an add function. You should rather be invoking the create function. Okay, so what if there is a double linked list and you're trying to add a value which is the smallest of all the values present here? Now in this case, you have two nodes, 10 and 20, and you're trying to add a node with the value 5. Because 5 is smaller than each of these, that's indicative that you're really trying to add the first node. Now you can check that if the value x, in which case this is 5, is less than the value that start is pointing to. So if 5 is less than the value that start is pointing to, then you really need to go and run another function which we are referring to as add first node x. Now the add first node x, I've rewritten, notice that I've drawn the first node and colored it with blue, including the previous and the next pointers associated with it. This I've done deliberately so you can have an idea of how these pointers change while we add the first node. Okay, now the add first node, I've deliberately kept the return type as void, because you are quintessentially keeping the two essential global variables, start and length, as global. So any change that's made is really reflected in these two. You don't really need anything in addition to that. So the void add first node, you're giving it the value x, which is 5. We've already determined that it is the first node. So the first thing is, you need a pointer that can point to a node, and A is pointing to a new node. So this ensures that in the memory a portion equal to the size of the node is allocated, and A is pointing to that. Then you can initialize this to the value that you want to put here. So A's value has been initialized to x. X in our case right now is 5. And then what you need to really do is that A's previous is pointing to null, and A's next will now point to this node. In other words, it's going to point to start. So A's previous is pointing to null and A's next is pointing to start. But remember, this is a double linked list, so there has to be in between two nodes, there has to be a node where this node is pointing to the next and this node is pointing to its previous. So right now the start is pointing to null, and we can change that. We can ensure that this node is now pointing to this node by stating that starts previous is pointing to the location that A is pointing to. Now you can redraw this whole thing in a different way, so it becomes it's a little messy right now. So let's make it look nicer. So this is another diagram which represents the same configuration, where A is now pointing to 5 and start is pointing to 10. And you can see here right now that A does become a double linked list. A does become the first node for this double linked list. So now if this is in fact the start and the first node, what is start doing pointing here? We really need to update this start so it doesn't point here, it points here. And you can simply do that by saying start has been assigned A. Now that we've established and put this at its association position, that's it. That's really it. All you're left is to increment the length global variable so that it updates by 1, right? So all add functions increment the length at the end of the function, and all delete functions decrement the length by 1 at the end of the function. Okay, so this is the whole add first node code, and you can try it while you run this while you watch this video and before moving on to the next slide or the next lecture. So we've already covered this, covers case 1 and case 2, and in next lecture we're going to discuss how to cover adding a node in the middle and adding a node at the end. Okay, as always, do try these codes before moving on to the next lecture. Okay, subscribe and hit the bell icon to get notified as newer videos get posted. Okay, up until next time, thank you very much. Bye bye.